chosen standing on the shoulders of giants. It might seem a little odd to all of you, but this is an ancient saying of 1159, as you can see. It simply means that we are actually standing on the shoulders. We are not greater than our predecessors, but they raise us to that level that we can take off from wherever they leave us. And to that effect, I'd like to actually thank and welcome amidst us today two giants from the Grand Medical College, Dr. Shubha Pandya and Dr. Asha Chakravarti. A lot of what I'm going to say today is material that has been collected by Dr. Shubha Pandya. If I start talking about her, that's going to be another talk. So thank you, Shubha and Asha, for being with us. So this is truly a moment of honor, pleasure, and all my sentiments as I'm sharing with you, that we are standing on the shoulders of the giants of pathology and microbiology. These are some names that I have thrown across the board, and I'm going to speak more about them. There are many more that I would have liked to include for want of time. So let's begin with a nice picture. I wasn't expecting Shubha to be here, and I'm really happy, but this is an old picture. I don't remember which year we visited the pathology school. And what you see here is the Teaching Pathologists Association of Mumbai and I, written by Dr. Gharpure. Again, a lot of the information is from Dr. R.K. Gharpure, and he has written it in this little booklet, which has been printed and reprinted. Of course, Dr. Shubha Pandya is my source of all the information. In the picture, you see Dr. R.K. Gharpure on the extreme left. Then is Dr. N.H. Wadia. I think many of you don't even know who these people are. Above is Dr. Abhay Chaudhary. In front, of course, is me, Dr. Asha Chakravarti, Dr. Shubha Pandya, and Dr. Jahangir Sarabji. All GMCites, all very committed, and all giants in their own right, except I might say myself, and I classify myself truly as a dwarf. So the early years of the Teaching Pathologists Association, it's interesting to note that this was a voluntary organization of teachers and students. And as Dr. Bijwe said, the first meeting was held on the 27th of July 1935 between two giants, Dr. Khanolkar, who was originally a GMCite, started as professor of the pathology at the Grand Medical College and moved to KM Hospital because they saw that it was more lucrative to move to KM. And then, of course, he moved to the Tata Memorial Center. And Dr. P.V. Gharpure, they decided that they would meet on a Saturday afternoon and discuss issues from different departments. So it was just an exchange of ideas, an exchange of information, obviously of cases that they have been seeing. So this was the beginning of the TPA. As you can see, it precedes the start of the Indian Association of Pathologists and then Indian Association of Pathologists and Microbiologists. And I hope that all of you are members of one or both of the organizations. It was later that Dr. Sokhi, who was director at Haffkine Institute, joined, and then 3 meetings were held in rotation. So it moved between KEM, Grand Medical College, and Haffkine. And when the MD Pathology program was started in 1938, and Dr. Khanolkar was the first MD teacher of the Bombay University, I'm just mentioning that Dr. Dyke was the first student, MD student of the Bombay University. Later on, the TNMC, which the Municipal College was started in 48-49, and Dr. Khanolkar moved as director of the Indian Cancer Research Institute. So there were, at that point, there were 5 institutions that actually contributed to the Teaching Pathologists Association. There was a very rigid format that was followed. It's interesting to note that we are required to maintain summaries of all the presentations. This is interesting. I don't know if it still goes on, because as long as I was in TMH, yes, we tried to maintain the summary. And I would urge all of you, because this is a gold mine of information that we have. I think you cannot have any archives like the Teaching Pathologists and Microbiologists Association, as I would amend it to be today. So a summary of the papers was maintained, and not only that, but one question was in the MD exam was always a topic discussed at one of the meetings. So this is an interesting point. Again, something that needs to be noted by the group of pathologists and microbiologists, so that you have questions asked at the MD exam. It just adds some clout, if I may say so, to the examination. Some of the important topics that were discussed, I'm just going to run through. An epidemic of typhoid in Bombay, where phage typing was done. We're talking about 1948. I think when I joined the MD program, we were still talking about phage typing. Today, we're still talking about virology. But look at the strength, look at the foundation we already have. Look at the heritage that we have, not only in this country, but at the Grand Medical College. I'm really proud that we are here as we stand and that we have done and contributed so much to science, pathology, virology, and microbiology at large. In 1952, Dr. Gharpure presented his data on schistosomiasis in India. I'm going to talk a little more about that at the 100th meeting of the TPA. And a summary of these 100 meetings was presented in memory of Dr. Khanolkar. It was actually dedicated to him in the Indian Journal of Medical Sciences. And I'm sure Shubha would have every volume that you want of this document. So if you need any information, please contact Dr. Shubha Pandya. She'll be more than happy to share this with you. In 1957, we witnessed an influenza epidemic in Bombay, and again this year we are witnessing right now an epidemic of unknown influenza. Some are calling it H1N1, some are calling it God knows what. I had gastroenteritis 2 days ago. I don't know what it was. I'll say it's viral. So the same picture is going on. We attribute it to viruses, known or unknown. But these anomalies in 1957, the congenital anomalies that were detected in the heart were actually seen on autopsies. Again, interesting data. And in 1964, they found a viral infection caused by giant cell bronchopneumonia, once again in autopsies, which was presented at the Teaching Pathologists Association. It was Dr. R.K. Gharpure who made the first contribution of 30,000 rupees from his own prize money to the Teaching Pathologists Association Trust. And later on, in the same year, 1968, this was registered as a trust. So that is the beginning of the money that all of us receive for our departments, some amount of research funds that are given. And I think the checks will be distributed today to the other colleges by Dr. Bijwe and Dr. Amita Katoj. In 1970, I think I'm not sure if this was the right thing. We separated microbiology, separated from pathology. Dr. Nadkarni was the first professor at the Grant Medical College. And after he retired, my father took over as the second professor of microbiology. But please remember, my dear friends, the TPA remained one and united. We have never separated. We have maintained this bond through the years and even today, with the exception that a new activity was added in the form of multiple choice questions. I was very happy to witness the MCQs today, both pathology and microbiology. The pathology, very colorful, morbid anatomy, as my father would have said, and the microbiology, more technical, in keeping with the topic that was being discussed. And the meetings were also considered as a part of the university teaching program. And I wish all our students, not only students, but all our teachers would attend the meetings. I don't see any of the teachers today. That's unfortunate. But I think the number of, we changed days because to improve attendance. I don't think that has helped. So maybe Saturday afternoon is a better time when everybody should be free if they want to attend. A few lines about Dr. R.K. Gharpure. He wrote a book called Hematobium G. I think I'm not going to give you some of the secrets that I share. I knew Dr. Gharpure personally. He was my father's teacher, a fine gentleman, very frank, but very much of a scientist. This picture is taken, I think, on his 90th birthday, which was celebrated at the Hafkin Institute. And you can see the cake in front. I managed to get a picture of the cake. It is lined with schistosoma. What a beautiful thought. That was a wonderful occasion. And Dr. Gharpure died a few years later. So let's run through some of the scientific data that I have, and that is schistosomiasis in India. None of this is my work, friends. It's all, I've been researching for quite some time, but it's been an interesting journey for me to just look at what people have contributed, and it's a yeoman contribution to science in India, if I may say so. So during the World War, Indian soldiers returned with schistosomiasis. At that time, we didn't know much about schistosomiasis in India, and we thought there were no intermediate hosts and there were no endemic infections. Dr. Gharpure was born in Gimvi, which is a small village near Ratnagiri with a population of 1,200. It's unfortunate I have never visited Gimvi, but I think my father went there once with Dr. Gharpure and they really enjoyed themselves. Besides the other activities that Dr. Gharpure and he indulged in, which I dare not spell out. Water supply was from wells, one rivulet running through the village. This is just some points, and they found in the patient's ova of schistosoma. This is some details of Dr. Gharpure's work, that schistosomiasis was endemic in India and in Gimvi for 60 years. He dissected 300 snails in search of the intermediate host. Not only that, but after dissecting the snakes in our Grand Medical College Museum, He had an aquarium. I think that aquarium doesn't exist. Dr. Bijwe may know if it's still there or not. But we used to see those tanks in an aquarium of snails which were cultivated in the museum, and he was breeding the snails from the endemic area. The second part was infection of the snails with Ferricius tenuis, of the snails with the Miracidia of schistosoma, then clinical survey and examination of the endemic foci with treatment, etc., etc. And the last part, which Dr. Gadgil contributed to, was establishing the life cycle of schistosoma hematobium in the laboratory of the Grant Medical College. So this is a summary of his work. Gadgil and Shaw reported this focus in Gimvi, a river that was passing through the village. They identified different species of intermediate host. This was a new species identified, Ferricia tenuis, for schistosoma. The patients had symptoms of hematuria in adults as well as children. The ova was seen in the urine of cases, and the bladder showed inflammatory changes. However, what is interesting is they did not see bladder cancers. We have so many squamous cancers of the bladder. Having spent my lifetime at Tata Memorial, I also tried actually do a small study, molecular diagnostics, to look at the antigen, the DNA of schistosoma and bladder cancers. Unfortunately, that study could not be completed. But the conclusion drawn by Dr. Gadgil was that the worm load was small, and that is the reason why probably we do not see bladder cancers. Yes, we do see squamous cancers, but as of now, we do not know the association between squamous cancer and bladder cancer in India. So much for Dr. Gadgil. I could again go on speaking because I have met Dr. Gadgil personally on so many occasions. He was very much in touch with all of us, and he came to the teaching pathologist meeting as long as he could walk. I remember having seen him, and I think the last meeting he probably attended was at the Tata Memorial Center, and I feel blessed for that. Dr. Raghavendra Rao, MD, DSc, OBE. It took me time to know what this OBE, Order of the British Empire. I think it is given to nationals who are not British nationals, but it is given by the British royals. Dr. Raghavendra Rao originally was a physician. I can see a frown on Shubha's face. I hope I'm not making any mistake. Shubha, please correct me if I go wrong. So Dr. Raghavendra Rao volunteered medical expertise originally as a physician. During the World War, he actually served as the honorary medical officer and senior physician. The picture you see on the right is actually the Prince of Wales Museum, which was used at that time as the Lady Harding Ward Hospital in Bombay. It's such a beautiful picture. We don't see these sites anymore. For his services, he received the Order of the British Empire in 1920. He was also, interestingly, the family physician to the Tata family, and he was instrumental in diagnosing leukemia, of which Lady Meherbai Tata died. And later on, of course, Tata Memorial Hospital was done in her memory. So that's again a strong historical connect. And because of this relationship, Sir Dorabji Tata donated 200,000 rupees towards the construction of the pathology school and the museum of the Grant Medical College. We are actually blessed by that. Incidentally, it was in 1909 that the coroner's court and the pathology lecture hall was built. So that was much earlier. The laboratories of pathology were located elsewhere. I think Shubha can fill us in on where the pathology laboratories were. But it was in 1929 that the pathology school was commissioned. And my next slide shows you that. So let's quickly run through the contributions of Dr. Raghavendra Rao. On the right, what you see are his publications. He worked on typhoid, plague, leishmaniasis, cutaneous leishmaniasis, malaria, rat bite fever, tuberculosis, and leprosy. If any of us has even contributed in one field, please raise your hand. I don't think any of us have done that. So look at the mammoth of information. Look at the quantum of knowledge that they generated in those days when they probably didn't even have oil immersion microscopy. So what were his contributions? Pure culture of flagellates and study of agglutination, serology of Kala-Azar, animal inoculations. Those days, a lot of microbiology was based on animal inoculations because we were all going by Koch's postulate. So you had to inject and then you had to isolate the organisms. And of course, he also worked on serology, agglutination, complement fixation, and the precipitation reactions. Again, malarial parasites in culture and observations on morphology. My dear friends, morphology is so important. When I was looking at the pathology quiz today, I could identify half the things because we have to be good morphologist. There are things that you have seen and you know, there are things that you are doubtful, and there are things that you really do not know that you need to search for. So this is what morphology is all about, and this is what I have learned over the last 40 plus years. Cutaneous leishmaniasis, oriental sore, he worked on culture, animal studies, and vaccines. Wherever you see, the topics remain the same. They're looking at identification, they're looking at culture, and they're looking at vaccine and vaccinology. All this material is from Dr. Shubha Pandya, and I'm really happy that Shubha is here to see what I have done with the material that she gave me a couple of months ago. Clinical and bacteriological studies in rat bite fever. I think I have even forgotten what rat bite fever is today because we don't look at these conditions anymore. But from 1917 to 1922, he published the appearance, he published a new species, and so much of information on the clinical presentations of rat bite fever. And of course, leprosy. Leprosy was something that was worked upon for all these years, and each of these giants, if I may say so, worked on not only the identification but also the isolation of M. lepri in culture, in various animals and other models. So the pathology school that you see today, and it's unfortunate that we're not sitting somewhere there and having this discussion, was inaugurated by Surgeon General Mackey on the 7th of June, 1929. And I hope that very soon, in the next couple of years, we will be celebrating 100 years of the pathology school. And I hope that I am there if we have some function. What you see on the left is the invitation. Below, as you're all aware, is the museum, and on the right is the Times of India clipping on how Dr. Raghavendra Rao's efforts continued, and because of him, we actually are blessed with the pathology school that we are all enjoying today. I'm shifting gears and moving to plague in India. This is just some of the initial studies. I would have liked to speak a lot more about Dr. N.F. Surveyor. Please note that there is a shift. You will see Professor of Bacteriology, Professor of Pathology. It goes back to bacteriology. So this shift has been going on because the focus has always been infectious diseases in the initial years because they were the major killers. Those were the outbreaks that we have all witnessed in the past and continue to witness even today. So this is a quote from the BMJ in 1896, written by Dr. N.F. Surveyor. A drop of blood was obtained on a sterile cover glass and put on a sterilized slide. The edges were sealed at once with paraffin. This specimen showed numerous small micrococca-like bodies which moved about rapidly. There were only a few bacilli resembling the plague bacilli. You will notice that I have to read some of these because these are direct quotes from publications. I dare not change what has been written by these giants. So in continuation with plague, I think you're all familiar with Dr. Waldemar Mordecai Hafkin, and the duration showed here is when he worked in India and at the Hafkin Institute. But please remember that his initial work was at the Grand Medical College in the Petit Laboratory, and I'm not aware of where this laboratory is or where it exists. Again, Shubha can fill us in with the details. But it's interesting to note that Dr. Hafkin was of Russian origin. He moved to Paris and then worked with, in 1889, he worked with Robert Koch on the cholera vaccine. Later on, in 1893, he was asked to visit Calcutta to study the cholera epidemic that was going on. And at that time, the picture you see here on the left is a report submitted by Dr. Hafkin on the cholera epidemic. In 1895, that the anti-cholera inoculations, or the so-called vaccine that they had devised, worked well. So he was actually asked to start his work in the Petit Laboratory, Grand Medical College, in 1896. His laboratory, and this I quote from a souvenir written at the Hafkin Institute, his laboratory was one room and corridor with a clerk and 3 peons. That was his laboratory. I need to move and show you the picture at the bottom is actually the stalactite growth of Pasteurella pestis and the plague vaccine. Actual studies done by Dr. Hafkin. It is so beautiful. I don't think any of you know about these stalactite growths. Be honest and raise a hand if you really do, till I go on to the next slide. So plague in India was epidemic in 1896, and it is debated that Robert Koch visited the Grand Medical College, but unfortunately he did not. He actually was a part of a German delegation that visited in 1987 and interacted with Dr. Hafkin when they also devised the anti-plague serum called the plague prophylactic, and this was produced in the Petit laboratory of the Grant Medical College. Later on, because of want of space, as I showed you, there was one room and some 3 pews and a corridor. They moved to the Haffkine Institute, which at that time was the governor's residence. Before that, it's interesting to note that in the Haffkine Institute, I think was built somewhere in 1565, the building, and it was a church. It was a church originally, and it has come down the years. And then, of course, Dr. Haffkine moved there. So at the same time, when Robert Koch was here, they visited the plague-affected areas of Daman and Diu, and they administered the so-called plague prophylactic vaccine, and then the plague research laboratory. So the names have been changing. Everything was moved to Parel, to the Haffkine Institute in 1902 to 3. And this is beautifully depicts Dr. Surveyor, Dr. Robert Koch, and Dr. Haffkine during that visit to the plague research laboratory in Parel. Again, Dr. Haffkine is somebody you can go on talking and talking, but I need to stop somewhere. And I assure you, I don't want anybody to fall asleep at this point on a Friday afternoon. Let's talk a little bit about Dr. Henry Van Dyke Carter. I brought in his name because I was quite impressed that Dr. Van Dyke Carter the drawings from Gray's Anatomy are all done by Henry Van Dyke Carter. What beautiful drawings. So they were all morphologists, they were all good at anatomy, they were all good at histology. Dr. Van Dyke Carter was the first superintendent of the GT hospital. He discovered the relapsing fever spirochetes in 1877-80 without an oil immersion lens. Please note that. He also worked on mycetoma, rat bite fever, and urinary calculi. And he described the appearance of Mycobacterium leprae, which you can see in that drawing picture on the left, how M. leprae actually looked. And Robert Koch described MTB in 1882. So it was a year later that he actually described the appearance of Mycobacterium leprae. So his studies on mycetoma, as you can see, beautifully depicted in presentations. The one on the left, on a new and striking form of fungus disease principally affecting the foot and prevailing endemically in many parts of India. Mycetoma, the fungus disease in India. Again, you can see the beautiful depictions and drawings of Henry Van Dyke Carter. Pathology of leprosy, and again I'm going to read what Shubha has highlighted in red. The description of Bacillus leprae as being usually shorter and more variable in dimensions, less bent, oftener bulging in center and thinning at the ends. I'm not going through too many details of these, but the characteristics that were found are described on the right, and I can leave behind the slides and I'm sure you can look at it. Leprosy in India was treated. The Infectious Disease Hospital of the Grant Medical College. Can anybody identify this structure? GMCite, quickly, come on. It's the Boys Common Room that was used as the Infectious Disease Hospital built in 1866. Do you see that? And it was actually used those days for lepers. There is a little inscription that talks about it. That's the story we have of Dr. Henry Van Dyke Carter. Now we move into the next era. Dr. P.V. Gharpure. I want you all to focus on his designation. Professor of Pathology, Morbid Anatomy and Histology, and Curator of the Museum. This is how pathologists worked those days. The period I've shown is 1926, 31, 34. He was acting professor from 1926, and 31, Dr. Gharpure was appointed as professor and head because I think it was Dr. Khanolkar who moved out. Yeah, moved to KEM. Anyway, that doesn't matter. So what were the contributions? Autopsy records. I was looking at autopsies today. I don't know why we don't perform autopsies. When I joined Tata Memorial, we were doing about 100 autopsies. The amount of information we gathered was huge. Today, autopsies, 0. I don't know how many autopsies Grant Medical College does, pathology, but we're not performing any autopsies. But most of the information comes actually from autopsies because you don't know what the patient died. And that's exactly why I put that question. What was the additional information from autopsies done in COVID patients? So Dr. Gharpure reviewed the autopsy records of 50 years, and he has described in a series of publications which I'm going to go through the incidence of primary carcinoma in India. He's also studied tropical splenomegaly in Bombay in 280 cases from 700 consecutive autopsies. And what is interesting is When we studied medicine at the Grand Medical College, every ward had a side room with a small laboratory. Believe me, this was introduced as part of the reorganization by Dr. Gharpure in 1934, when every ward of 30 beds had a lab and a clinical side room. So it was from that time. I don't know if those side rooms exist anymore, but I think we need to go back because some emergency tests can only be performed at the bedside. It's so important to recognize what these giants did and the heritage that they have left behind, which we are actually beginning to forget as time goes by. I'm going to read from a talk given by Dr. Gharpure. Please excuse me for that. I never read somebody's works, but this is interesting. While going over the records available in the pathological department of this college, and while remounting the specimens in the pathology museum, I was interested in a large number of similar wet specimens and their descriptions. These roused my curiosity to collect and compare the notes available, both clinical and those obtained at autopsy. I believe that such a study may be, to some extent, instructive. I managed to collect such primary carcinoma cases as were available with their notes and microscopical findings. The subject I have selected today is the consideration of carcinoma as it affects 4 organs, wherein it is often a matter of doubt or difficulty to decide its nature, whether primary or secondary. My investigation relates to primary carcinoma of the liver, stomach, pancreas, and gallbladder. The rarity of this affection in 4 organs under consideration may well be judged from the fact that only 36 cases have been recorded in a collection of 6,000 odd during the last 50 years. So look at this phenomenal data that we must have looked at that time. And this is a summary of the 36 cases. 14 had liver as primary, 13 had carcinoma of the stomach, 8 in the pylorus, 2 cardiac and 3 body over a large area, 7 with primary carcinoma of the pancreas. All had secondary deposits in the liver, mesenteric glands, and the peritoneum. 2 cases of carcinoma of the gallbladder, 1 in a 70-year-old male and 1 in a 40-year-old female, both with secondary deposits, meaning metastasis in the liver and the omentum. Such a thorough study. Again, another of his works, which I think you can keep the slides and go through it. I'm not going to spend 4,000 autopsies, 131 primary malignant tumors. This is more or less the same. So I don't know how they could perform autopsies, how they could analyze such data. I have done manual data analysis myself. Today you have the benefit of computers, but let me tell you, you put data into a computer and it messes up everything. It all depends on the terminologies you use. It needs to be standardized. To me, it's a headache. I still look at my registers. I can see Kashyap in the background. I've made Kashyap analyze data, how many cases, 10 years, tuberculosis. Even if you have 6,000 cultures, still analyze them manually. And rest assured, you cannot go wrong. But with computers, you can go wrong. And that's the kind of work that our giants and forefathers have actually done and helped us to move on further. Dr. V.R. Khanolkar is referred to as the father of pathology and research. Any amount of information on him is going to be inadequate, so I have made the shortest possible slide. I often ask this question to the MD students at Tata Memorial when I was there. What is the ICRC bacillus? I don't think any of you know it, and I don't expect you to know it because if somebody from TMH doesn't, I don't expect this group to know it. But the ICRC bacillus was cultivated by a group of scientists, of which Dr. Khanolkar was the leader. I will ask you the next time's quiz, please put in the names of the other scientists connected with the ICRC bacillus. I'm not going to tell you all that. The cultivable form of M. lepri from human lepromatous nodules in human spinal ganglia. That was one of his biggest contributions. But he received his MD in pathology from London University 1923. As I mentioned, he was a professor of pathology, Grand Medical College, moved to KEM, and then he moved to the Cancer Research Institute. He was the founder of the Indian Association of Pathologists, and that's why he's known as the father. He also obviously founded the Teaching Pathologists Association. He published 3 books on cancer and leprosy and more than 100 scientific papers. Dr. Khanolkar also set up a registry where they actually had information from the African countries on cancer. I've not mentioned that, but the more you read about Dr. Khanolkar, the more there is to read about him. And that's the kind of person he was. He pioneered biochemical, cytological, genetic, histological, and statistical aspects of cancer, and that was the basis of the Cancer Research Institute. He was the first to recognize that tobacco was a causal factor in oral cancer. He established tissue culture systems, carcinogenesis. The entire Cancer Research Institute was the creation of Dr. Khanolkar. I don't think I have said enough, so apologies for not being able to say any more, because that will be another talk on Dr. Khanolkar. The last of the giants that I would like to speak about is Dr. C.G. Pandit. The first giant, Dr. Gharpure, and the last giant, Dr. Pandit, are both people whom I met personally. Dr. Pandit came home to see us in Pune because he was very close to my father. And the book that you see on the left is certainly worth a read. I had a copy autographed by Dr. Pandit. As usual, somebody borrowed it and never returned it, so I don't have it now. I'm looking at an electronic version of the same book. That's the curriculum of Dr. Pandit, but his contributions again on infectious diseases, cholera and filariasis. Again, he manufactured a bacteriophage to control cholera and dysentery. He worked in virology. He was a highly qualified person, trained both in the United States at Johns Hopkins as well as in the UK. He performed experiments on vaccinia virus, yellow fever. Those days he worked in the Adyar Institute in Madras. And the filariasis was actually known as the curse of St. Thomas. That was what it was known as. But he discovered that a garden lizard harbored the larvae. And not only that, he went on to infect he went on to infect the lizards by collecting Culex fatigans mosquitoes, estimating the microfilaria rates. Look at the amount of work. He looked at 2,000 mosquitoes and found how many were infected and how many had infected larvae. This is a huge article in itself that he writes about. Not only that, he started a filaria clinic, prepared a vaccine locally from a streptococcus strain that he isolated from a case of filariasis. And from this, he actually writes about what is known as the Pandit's reaction. The sera of cases treated for filariasis, obviously which are antibodies from filariasis, were treated with microfilaria, and you found that the microfilaria adhered to leukocytes and then they died. So this was known as the Pandit's reaction. A living example of serology as we perform today, or as we would like to perform, looking at the death of parasites. Outbreaks of cholera, meningitis, and infectious hepatitis, again, his contributions. It's interesting to note that in 1936, there was an outbreak of cholera, and it was sourced to a sannyasi who gave the water as holy water to the devotees, and 109 attacks and 53 deaths from this one sannyasi. I don't think this is quite common, and I often wonder why the water from the Ganga, as we say, Ganga Jal, is stored in copper containers. Again, a question that you need to think about. Let me tell you the answer. Because copper actually has disinfectant properties. So when you store water in a copper container, it gets sterilized. Maybe that's why, because the water can be contaminated and then you have outbreaks like this. Dr. Pandit used the cholera vaccine as well as the bacteriophage for treatment of cholera. In 1938 in Madras, there was another outbreak of meningococcal meningitis in a village in 1 week, where there were 41 attacks and 22 deaths. Now, this was actually attributed to one case who came from outside, overcrowded homes, and that one case transmitted to so many other patients. Epidemic of infectious hepatitis in Delhi in 1955-56. This is interesting. Later on, we know that this was an outbreak of hepatitis E. Again, we've had hepatitis E in the years to come. Later on, I think it was in 2003 onwards that we've been seeing hepatitis E, and it is now endemic. So the first reported epidemic, and this was investigated by Dr. C.G. Pandit in 1955. He was the first director of the Indian Council for Medical Research, and he introduced medical research in medical institutions. He also established the NIV Pune, which was then called the Virus Research Center. He established the Center for Research in Poliomyelitis, which was initially at the Grant Medical College under Dr. P.V. Gharpure. Dr. P.V. Gharpure, pathologist, but you can see he worked in polio, and then this was shifted to Hafkin, where Dr. Gharpure, which was later known, I think, as the Enterovirus Research Center, and was headed by Dr. Kanu Dave, if I'm not mistaken. So that was the creation of Dr. C.G. Pandit. The Tuberculosis Chemotherapy Center in Madras, which still exists as the Tuberculosis Reference Center, I think, if I'm not mistaken, in Madras. and the Cholera Research Center in Calcutta. So these were the four major institutions under the Indian Council for Medical Research, and all of these contributions of Dr. C.G. Pandit. My last two slides, 4 decades of laboratory medicine, as I call it. As I close in on the finish line, excuse me if I get a bit emotional. I started my mentor, my father, at the Grand Medical College, Tata Memorial Center, where I was standing on the shoulders of two giants who helped me move and complete this vision. Everything you see in this slide is what I could do at the Tata Memorial Center. Starting with the Grand Medical College, I started with a small department, 1 room, 4 technicians. Then Amita talked about waste management. We had a world-class center which was treating infectious waste, applauded by the World Health Organization. The day I retired in 2019, I left a department recognized for MD microbiology. We had every possible test that could be performed and that was required for cancer patients. And let me acknowledge all the giants who have supported me, including my colleagues, my friends, and of course the staff that has worked with me. I come back to some reflections. I mentioned to you that I'm a dwarf standing on the shoulders of a giant and possibly see further than the giant himself. A few reflections and lessons that I have learnt in my last slide. Pathology and microbiology have a non-negotiable marriage. Please do not separate the two subjects. Please do not move away pathologists from microbiology and microbiologists from pathology. They are both interpretative sciences. Please do not work like technical people. Techniques are important. I learned a lot from my technologists at the Grand Medical College. I don't see any of them here because they have all moved on. But yes, it is an interpretative science, and that is our specialty. Morphology is the foundation of diagnostics. If you are a good morphologist, you will be a good pathologist, a good clinician, a good microbiologist. Treatment is required for diseases, not conditions, and infections, not microorganisms. If you have a condition, it doesn't mean you have a disease. That's what I mean, because with infections, I know when you see a microorganism, it doesn't mean that there is an infection. Direct examination of specimens often indicates the diagnosis, and that's the importance of tests like calcifluor white for diagnosis of any fungal infections. So please move on to establishing rapid tools for diagnostics. Technology and automation are important, but the man behind the machine is more important. My dear friends, this is the most important statement. Today, everything is put into a machine. Oh man, this is Candida auris. It is not Candida auris. Have you seen what it looks like? Have you seen the growth? Have you seen the patient? Have you seen the slides? What you're calling Candida auris may be Cryptococcus. The machine does not know what it's doing. So please do not depend on automation and technology alone. This has been my fight against the current generation. Just a word of caution. And finally, a statement which my father used to make every second day, and I fought with him. And I'm repeating it today after all these years. No one is ever really taught by another. Each of us has to teach himself. This is a quote from Swami Vivekananda. Thank you so much for listening to me.
I think everybody must be spellbound. What a wonderful and rich history which Madam has told us. And really, many times we look to the West or other countries for our inspiration, but forget about our own people. And I think it is very, very important that what we had, we must preserve that, and we must take the inspiration from our people who had really given their lives. So once again, Madam, it was a really, really wonderful talk. Thank you so much.